Hello, everyone. Welcome to our first session of our online course, BIM Basics for Quantity Surveyors and Cost Estimators. We'll just wait for another minute or two to get everybody that have signed up to join. It's great to see that so many people signed up for this course. So I'll just give you a little bit of a background of the idea of the course. We've seen that there is a lot of missed opportunities in regards to BIM and quantity surveying, and we believe that there is definitely a lot of gaps in the industry and in the knowledge about BIM. And we think that with these three basic sessions, we'll give you the fundamentals that will make you a lot more confident when it comes to BIM modeling and also BIM management. In the first session, we will talk about the BIM authoring tools, BIM modeling in general. In the second session, we will talk about BIM management and how you can actually make the stakeholders deliver the models that you need as cost estimation professionals. And in the third session, we'll make a roadmap or plan a project, how it's best to structure your next project in order to get BIM up and running, and also perhaps set some more ambitious BIM goals than you would usually do. So in this session, we will talk about the various BIM uses. We will see the various also dimensions in regards to BIM, from 3D BIM to 10D BIM. We'll review some BIM modeling software solutions, and then we'll talk about the problems you might have with BIM models when it comes to cost estimation. When you know where you might have a problem, it's most likely that you would be able to detect those problems and eventually fix them. At the end of the session, we'll talk also how to make use of the BIM models, and we'll see what kind of stakeholders we have involved in the whole process. Just a couple of words about this BIMmetry. We are a BIM consultancy based in Melbourne. We're working with quite a lot of prominent organizations. We do both project work, so we support companies on project basis when they need BIM modeling, 4D sequencing, BIM management in general. And we're also very much involved in software solutions such as Cubicost. We are authorized reseller for Cubicost in Australia. It is a 5D BIM tool, so if you're a cost estimation professional, that might be a very interesting tool for you to look at. We are also distributors for Plannerly, which is a BIM management tool, and ZWCAD, which is advanced CAD solution. Except of our reselling activities, we also do software development, and we have developed our own tool called Plan Construction, and it is used to make rationalization of construction sites and also storyboards for 4D sequences. If you want to learn more about this, please let us know. We were always happy to schedule a meeting and see if we can be of any help. Glowdon also support us in this course. So at the end of the course, you have a short test that basically goes through the content, and you can get a certificate about the BIM fundamentals from BIMmetry and Glowdon. Okay, so let's have a look at some scenarios that you might find yourself in regards to BIM models. BIM has been around for quite some time, but you might not have found a way yet to make use of it. So this is why we wanted to make this course, to give you the fundamental understanding of BIM and make it a bit more accessible. Usually, there are three scenarios in which you can find yourself in regards to the BIM models. In the first scenario, you get a new project and you know there is a BIM model, but you have no idea what is the quality of it, what is the LOD or the level of development, how recent is the model, how well it's been modeled. Well, in that case, what you should do is to check the model. And further in this course, we will discuss what problems you might find along the way, and also how to fix them to a certain extent. In the second scenario, you might have BIM models that you are very certain of in terms of quality. You also know there is not only 3D geometry, but additional data attached to the models, such as cost. You might go forward with more confidence and directly extract the quantities and the estimates, but still, you might want to use a tool such as cubic cost in order to get extra quantities like real and formwork. Also, you might want to get automated deductions and format the estimates in the way you want. In the third scenario, the design consultants might have issues with sharing their models. This is because they might have their own BIM content created, which comes with copyrights and IP. But there is a workaround this, as you don't need their content except for the quantities from it. You just create a cubic cost file by importing their Revit model, or you can just directly ask them to import their BIM model into your cubic cost license. This is not anymore a native Revit format, so the consultant's IP and copyrights are protected, and in the same time, you have managed to do your job. So this is all a matter of discussion. Just make sure when a consultant doesn't want to share their model to ask for the reason behind it. BIM So let's start with what is actually BIM or Building Information Modeling. The keyword here is information. When we talk about 3D modeling, we usually just call it 3D modeling. But in the case of BIM, we have 3D models and information or metadata linked to the 3D geometry. This information is indeed quite useful and gets used in various processes and programs through the life cycle of the building. Another important abbreviation to be aware of when we talk about BIM is LOD, or the level of development of the components. The scale on which we measure LOD is 100 to 500. NatSpec have a very useful document for the definition of LOD if you want to learn more. But let's quickly explain this scale. When we say a model is in LOD 100, we usually mean concept design. There are components, but it's not their final version. If we pick an example of a chair, we have put an object, but it is still very far from the actual chair that would be placed. LOD 200 is the model when it is in design development phase. LOD 300 or 350 are the models we use for construction documentation. LOD 400 is model from which we can fabricate, so we have all the nuts and bolts in this component. LOD 500 is as-built BIM model. As we mentioned in BIM, we have additional information, and one parameter of this metadata is usually cost. If we have prices in the BIM models, depends on the level of development. In LOD 100, we can't expect to have cost parameters filled in yet. Usually, we make per square meter estimates based on the BIM model. In LOD 200, we can extract the quantities from the BIM models and give some approximations. Often for LOD 300 or 350, we have requirements for the data in the BIM models, and actually you could have specific data and prices filled in for the various objects. In LOD 400, we are expected to have the actual prices linked to all the components for fabrication. And in LOD 500, we have the actual operational and maintenance costs. Why do we mention all this? Because of QS and cost estimation professionals usually get BIM LOD 300 or 350 models, and they might already have some prices filled in by the design consultants. It all depends on the requirement they got when they were doing the BIM models. So it might be a good idea for you as a quantity surveyor to check if those models actually have already some prices related to the various components and the specifications. You might want to use these prices and estimates just to do comparisons, or it is generally useful information for you to have, and it is always good to be aware that you have this information. And now let's have a look at the BIM uses. Now let's have a look at the BIM model uses. Why everybody needs these models and what they can do for them. In the conventional design and build process before BIM, all the 3D models and 2D drawings were mostly of an interest during a certain phase of the design and build process. The case with BIM is slightly different. The BIM models can be of use during the whole life cycle of the building, long after construction has finished. A number of stakeholders are interested to have the models. That's why we need to start with the end in mind. During operations, the BIM model becomes a sort of a dossier for the building. You can use various software where your BIM model becomes digital replica of the physical asset. And to each component, you can attach various maintenance information. You can use notifications for certain objects that need maintenance and see in a web browser in the BIM model exactly what and where needs to be fixed. There are a lot of tools that can make the models useful for the facility managers, the owners, and the final inhabitants of the spaces. Even without specialized FM software, having the BIM model can help for future maintenance, renovation, and reconstruction. By simply opening the model and seeing where the installations are, who installed the items and when, the manufacturers and the cost, anyone that is responsible for a building will have a great resource to look at. BIM models can be used to be linked with the BMS and IoT systems. So you can select a particular room and switch on and off the light in the cloud, which will actually switch on and off the light in that physical room. Considering all the security issues that come with these new technologies, the industry is moving towards this direction. The construction companies are also interested in the BIM models, and there are so many tools nowadays that can make their life easier and improve the quality of the construction product. One quite common scenario in which a general contractor might want to have the BIM models is to run a 4D construction animation sequence. 4D sequences are 3D animations linked to the construction program. The sequences help rationalize the construction on site. We, as Bimetry, have developed a tool called Plan Construction. It is a specialized web platform which helps you create a storyboard for your 4D sequence. 4D sequences have different purposes, from internal construction variation rationalization to marketing and public dialogue medium. Companies start to make more often also 5D sequences, where the animation is not only linked to the program, but also to the financials. And this is where you, as cost estimation professionals, might want to get involved as well to test various scenarios in terms of 4D sequence and what would be the impact on the budget. Contractors often do scan to BIM, which is a 3D scanning of a site or a building to produce accurate as-built drawings or to study existing site or existing construction. Developers, on the other hand, might want to use the BIM models for space management and tender management. There are a few tools that are specialized for the developer's portfolio asset management, which is different to the FM tools. But let's see now how the BIM models are useful also for the consultants. Design consultants use BIM to produce 2D documentation and 3D visualizations. You can use the BIM models to make AR and VR walkthroughs the model. As we live in three-dimensional space, The 3D representation helps us a lot to visualize the design before building it. It also helps us to make clash detection. Here is the moment to mention that as we have multiple consultants on a construction project, so we have multiple BIM models. We usually have architectural firm producing the architectural model, structural engineer modeling the structure, MEP consultants doing the services BIM models. All these models get linked into a single file, and by visual digital inspection of the models, we can see easily any clashes that might be happening. As we mentioned before, the keyword in BIM is information. The BIM authoring tools make a difference between the object categories, and we can extract structured data in spreadsheet format. For example, we can extract all the quantities and price details if we have inserted the cost. As QS and cost estimators, this information might be very valuable. Even if it's not always complete or 100% accurate, this can speed up your work a lot. Let's see how you can use the BIM models as QS consultants. We already mentioned that you could get involved in animated construction simulations, including the cost, the so-called 5D sequencing. You can also get the BIM models, extract the quantities, and speed up your work greatly. For example, Cubicost can help you do that. All you need to do is insert the Revit model into Cubicost, and you'll have all the quantities structured, which you can further manipulate and add cost to them. The great thing about Cubicost is that it will not only extract the quantities, but it will make automated deductions, which the BIM authoring tools don't always do. So if you have a window, for example, the volume will be automatically deducted from the wall mass. Cubicost will also generate automatically the quantity for your structural components, reinforcement, and formwork. You basically need 1 minute to import the model, and 50% of your cost estimation job is done. The other great feature of Cubicost is that it will notify you in case you have overlapping geometries, which happens quite often with the BIM design models. But what happens if you don't have a BIM model and you only have 2D drawings? You can still automate your work greatly using a tool such as Cubicost. You can basically select the outlines of the components such as columns, beams, walls, and others, and you can generate a 3D cost model based on the drawing lines and schedules. This is a lot quicker than if you would do it manually. Cubicost is much easier tool to learn compared to the sophisticated design BIM authoring tools. It is designed for QS and cost estimation professionals. Last but not least, you can automatically estimate complex curved geometry like ramps and sloped walls, including the RIO and the formwork, and generate in 3D all the finishings from the architectural schedules. So everything you would base your cost on is an actual 3D geometry, and you can visualize all the deductions in 3D. And finally, if you're a QS and cost estimation professional, you could use BIM model just to cross-check your manually generated estimates compared to the automatically extracted ones from the BIM models. It is always good to double-check quantities and estimations. Yet, when we use BIM for 2D, we usually mean that we extract drawings from the BIM model. A drawing is two-dimensional representation as it only has width and height. Of course, we use BIM also for a lot of 3D purposes where we have the Z-axis, which gives us depth. We can use BIM models to produce 3D renderings, AR and VR walkthroughs, and 3D animations. Not every animation, though, is actually a 4D sequence. We call it 4D BIM when we link the 3D geometry to the construction program, so we give to the representation the fourth dimension, which is time. The 5D BIM simulations are 4D sequences with the component of cost. So we link the animation not only to the construction program, but also to the budget. We also use the terminology 5D BIM when we talk about 3D cost models like the ones created with Cubicost. 6D BIM is usually when we talk about models used for energy performance simulations. So far, companies have widely adopted and implemented BIM up to 5D BIM, and the terminology is clear. From 6D to 10D BIM, we see different interpretation of these terms depending on the context. Often people don't make a difference between a 3D modeling software and BIM Autorec tool. For example, BIM Autorec tool is Revit, ArchiCAD and Vectorworks. They produce 3D geometry, but every object is recognized by the program as a different category with certain properties. For example, a column is a structural component. It has material, profile, cost, and so on. The 3D modeling software, such as SketchUp and Rhino, also generate 3D geometry, but it doesn't have the metadata that the BIM models usually have. There are plugins and workarounds to turn this 3D geometry into BIM models, but essentially this is the major difference. Revit produces 3D geometry and metadata information, while 3D Studio Max is used when we only need 3D representation without the additional information. This is good to be remembered, as if you hear that certain model was created in Rhino, then you might not have the data you need from this model. You can reference the 3D geometry, for example, in Cubicost, but you might not be able to extract the quantities that you usually would be able to extract from Revit. The reason being is that, for example, panels won't be recognized as panels and columns won't be recognized as structural members. So it is very hard to schedule the quantities in different spreadsheets as you would usually do from Revit. Now let's have a look, a quick, very brief look at the interface of Revit. You might often find yourself in the position to just open a Revit file. It is good to know the very basics. So on the left we have the properties and the project browser. Basically, the project browser is where you have all your set views, like plan views, sections, 3D views. You can just click on the various views and see what is in there. On the top, you usually have the instrument. So if you're in a position of a QS, you would rarely want to use those instruments. It is mostly for the designers. We can see we just select one instrument and we can draw a wall. One thing that is good for you to know if you ever happen to open and inspect a Revit model is to be able to select an object and have a look at the properties. Basically, you select it and have a look on the left and just see what parameters are there. If you have a lot of metadata, you would immediately see. You just saw on the screen 2D lines that were following the contour of a door, but weren't actually a real door. This is something to be mindful of. A lot of designers sometimes use 2D lines to do their drawings, but don't draw the object, or they don't load the object. This is important because you might have everything on the drawings, but you don't get it in the quantities. This might be one of the reasons, because some objects have been drawn just in 2D. And you can very easily open in Revit or open in Cubicost and have a look and see if that's the case. Basically, this is the 2 or 3 things that you need to know when it comes to opening Revit. If you happen to not see the project browser and the properties, you can go to the View tab and Preferences and you can switch it on. You can also create additional floor plans or sections, which are very basic commands in Revit, and usually cost estimators don't need to become expert in the Revit software, but at least it's good to know what to do if you quickly need to open a Revit file and check something. Comparison to Revit, we have made a screenshot of Rhino, which is a 3D modeling tool. As you can see, it is quite similar to Revit, but the big difference here is that the geometry we see here on the right, you can see the properties. We don't have any metadata, so we don't have parameters such as manufacturer, material. We have actually material, but just for visualizations. We don't have fire rating, for example, or things like that. And you can see that with Rhino, we can create quite complex curved and organic geometry, something that usually 3D modeling tools are a lot better than BIM modeling tools. So I'm just giving you this tip. If you see some sort of a project which has a lot of curves and organic shapes, you immediately might think that part of it has been designed not using Revit. And this is the moment when you could ask if this geometry has been transferred in Revit and if it's actual BIM or if it's just geometry. Just because if you want to rely on the models to get quantities, you want to know what is pure 3D and what is actual BIM. Now let's see a little bit more about the BIM objects. Most authoring tools have some preset parameters for the BIM objects, but there are already established standards and classifications which add on top of the default parameters a whole new level of complexity. These formats and classifications, such as COBie, OmniClass, UniClass, IFC, are usually requested by the BIM leader and are intended to serve the FM software that will be used during operation. Basically, the whole process is adding extra parameters to the BIM objects, and the consultants or subcontractors on the project fill in this data. Sometimes this is a lot of information and includes parameters such as cost. As we can see a random example for a curtain wall object, we see how many parameters for cost we've got. Imagine a scenario that you have a BIM model and someone has spent all this time to fill in the data for every single object based on the specifications. As QS and cost estimation professionals, you don't want to miss on this information. For this reason, it is good to get informed on what is included in the BIM models and if you have any metadata. If you can have all this information extracted and structured, why not make use of it? Now let's see some of the BIM modeling hurdles that you might see in your everyday work with BIM models. So as with the example with Rhino, you might have complex organic geometry such as stadium canopy that has been modeled in a 3D tool and imported into the Revit model. In that case, your quantities might not come up as you would expect them. Structure might not be detected as well as the other pieces. Using cubic cost, you can still use this geometry as a reference to create the model as a 3D cost model. This is a very common scenario to have certain objects not modeled in the correct category. For example, stairs might not be modeled as stairs, but just as generic mass model. And of course, in your quantities, you won't pick up stairs as stairs. As we saw in the Revit interface video, often we have 2D lines instead of actual 3D objects, but it still looks okay for the drawings. The problem comes with the scheduling. There might be also some naming mistakes in the model. For example, two identical windows can be named as two different types. So in your schedule, you might have two absolutely identical windows that have been nominated as two different windows. This is probably less common scenario though. There are just general recommendations to be followed in regards to BIM modeling. And of course, the first one is to model everything in the right category. Another thing to be aware of that is very common in the Revit life is that you can have two walls overlapping, and then your quantities, when you extract the quantities, you get double the number. So your quantities might not be correct. Tools like Cubicast resolve this as it notifies you when you have overlapping geometries. So basically, how we can fix these issues. One thing you can do is to get involved, if you get the chance, of course, to get involved in the early design stages, where you can say that you are going to use your model for quantity surveying, and that these kind of things are important to you. So this can be included in the BIM execution plan. This is the document that usually the BIM leader is writing specifically to every project. And there the BIM uses are defined. So if the models are going to be used for quantity surveying, they might add additional modeling requirements, such as not have duplicating geometry, such as modeling everything in the right category, such as including the cost that is related to the object specifications. All these can be included in the early BIM execution plan, and the designers from very early on work towards BIM models that are good um, for quantity extraction, basically. The second thing you could do, if you don't get the chance to get involved in the BIM execution planning, is of course to do model reviews. You can do both visual reviews, as opening the models in Cubicast or in Revit, or you can do automated reviews, and there are tools such as Solibri and Navisworks, and many other tools, by the way, which can help you do analytics of the models and get some generic figures on how well the models have been modeled. And another, let's say, more manual way, of course, is just to choose a portion of the model, do manual cost estimation and quantities, and then do automated estimates and see how it is in terms of overlapping, or is it too different. If you get very different figures, you immediately get a red flag saying maybe some geometry hasn't been modeled in native Revit, it's an import, so that's why it's not picked up. Some geometry might be just 2D lines, or you might have a lot of overlapping geometries. Usually it doesn't take long to realize what is the state of the models. Now let's have a look at the people that are usually get involved in BIM modeling. On project which has a lot of BIM requirements, we typically have a project BIM lead, BIM manager, who can be client side, construction side from the construction company, or on the side of the designer consultants. Usually that might be the architect. So it very much depends on the contract, who will be the BIM lead on the particular project, and also the capabilities of the organizations. Most of the consultants have a BIM office lead. So this is a person that sets the standards for the whole organization. But you also have a responsible BIM manager on the side of the consultants on every particular project. These people are usually more interested in things like BIM data or BIM execution plans, and they're the right people to talk to in regards to special quantity surveying requirements. In the next session, we will talk about incorporating specific requirements in regards to the BIM models in the BIM execution plans, and how to basically handle this whole process. The BIM modelers and the BIM coordinators are, of course, part of most of the design organizations, but they don't necessarily always get involved in the BIM execution planning and things like that. They're just producing the models. And this is where usually some mistakes might happen. So it is the job of the BIM managers to communicate to the BIM modelers what is expected from them and what to avoid in a particular BIM modeling scenario. The document controllers, of course, they control the BIM models on platforms such as ACONNEX and Procore. So basically that is it for today. I hope some of the information was useful. If you have any questions, I suggest now is the time to ask in the Q&A window. And after this session, you'll get an email with additional references, the recording also of these videos. Yeah, basically we'll be happy to have a conversation with you if you have any further questions, if something wasn't covered well enough, if you want us to cover it further in some of the next sessions as well. Please let us know. So I don't see any questions coming yet. If you don't manage to attend live some of the next sessions, again, you'll be getting the whole session recorded. And at the end, on the third session, you'll get the test, which you can, it won't take long, it will just take you 5 to 10 minutes, and then you can get a certificate for the BIM Basics or BIM Fundamentals course created by Bimetry and Glowden. Well, I don't see any questions coming. Thank you everyone for attending today. It's great to see such a diverse audience of participants from QS and also construction companies and project management. That is something that actually inspires us a lot to spread a little bit more the knowledge of BIM. We don't want to make these sessions too professional or too expert level, so we want to make BIM a little bit more accessible. So please tell us if we can do something better. If we have structured something and it's not understandable, let us know. And yeah, have a great day and hope to see you soon.